Hi, sorry for the inconvenience. So, welcome everybody to the webinar Applied Domain Driven Design on Legacy Code. Like you've seen in the presentation title, we have two words, domain driven design and legacy code. So let's start by introducing them. So yeah, before that, if you need to contact me or if you need to know who I am, so I'm a Globe-trotter developer. So I've worked in Tunisia, then in Paris, in France, and also in many companies in Europe. And right now I'm based in Montreal. I'm also the co-organizer of the Software Crafters Montreal meetup, and I'm a co-founder. I'm one of the co-founder of SOCRATES Canada. If you need to know more about me, you have my website. And if you need also to book me, you can find all the information, all the contact information right there. So what is actually domain-driven design? So what you need to know, domain-driven design is an approach created by Eric Evans, focusing mainly on business, not on technical aspects. The thing is, Eric Evans, when he started talking about that, he already said that usually, mainly the developer, they focus only on the technical side and they forget completely about the business side. But what you need to know is when you create an application, it's usually for some business needs. So if there is no business need, there is no application. Also, the thing that you need to know is that domain-driven design is decomposed in three parts. One of them is knowledge crunching. What is actually knowledge crunching? It's an activity between the domain expert and the developer. They're gonna analyze some use case, some user story, some scenarios, something, some business need. And from there, they're gonna generate what we call an element of a language, of ubiquitous language, or maybe what we call a shared language between the domain expert and the developers. The element of this language, it can be some kind of concepts and definition, and the glossary of definition. Also, a candidate solution model, because we can have multiple candidate solution model, and sometimes also some few sketching and few mock-up to the application. This is the first part about DDD. So when you are talking about the solution model, what is actually composing the solution model? So usually the heart of the model itself, we have two kind of concepts that you need to know. The value object. The value object is a structure that contains value, that is immutable, that hasn't an identity, or actually, let's say its identity is all the values that have, and the entities. I'm sure you know about entities. It's the same definition that you know everywhere. It have an identity, it have a life cycle, and the value in it are mutable. What you need to know is an entity can reference entities or value object, or even both. But value object can only reference a value object. So using these two concepts, we have the aggregates. And aggregates, actually, it have an entity as a root aggregate, and that entity gonna reference entities and value objects. Let's say if I take an example, if we take a car as an aggregate root, it can reference, for example, the entity wheel, and also it can reference an entity like engine identifier or something like that. So the aggregates actually have a life cycle. That life cycle is managed by repositories. Okay, so sometimes when the aggregate is really too complex to be created, we use factories to do that. There is also another concept that I'd like to introduce to you. If we have some kind of business operation that is not natural to do it in AntiZ, not in value object, a pure function, let's call it a pure business function, we call that a domain service. So that's another concept. And in the last few years, we introduced a new one because we started talking about event sourced system and also about let's say events and all the stuff. We now talk also about the domain event. It's also one of the component of the entities. It have similar properties as value object. It is immutable. It can be changed. It has a timestamp. It has so many things that you need to know. Also, what you need to know is that we are talking about layered architecture, but right now the thing is we are moving more to hexagonal architecture. I will not talk about that because it's not really the subject of the talk right now. So the thing is, at some point, that model can become spaghetti by the time with the new feature or all the stuff. So what we can do to keep it concise. So to keep it that way, we use what we call strategic design. This is the third part about domain-driven design. One concept is the bounded context. Actually, when you are talking about the model, at some point we need to split it in small pieces to reduce the complexity. And these kind of pieces, this is what we call bounded context. So at some point, you're going to have small pieces with lesser complexity than a bigger one. At some point, these kind of pieces needs to communicate between each other. So there where you introduce the context map and all the patterns that you can use to do that. You have the shared kernel. So at some point they're sharing some kind of structure. You have the customer supplier. So one bounded context can be a supplier of an information, and another one is really a consumer about that. You're gonna have the conformist. The conformist is like one bounded context has a model, and another one is gonna use it as it is. It can't modify it, and is gonna include it directly in his model. We have the open host service. We're gonna talk about that in details. And sometimes also the bounded context, they don't communicate at all. So we are talking about separate ways. So yeah, that's the good stuff that we are talking about DDD, but wait a minute. We're not here to talk about DDD, right? So now we're gonna talk about the other part of the subject, the legacy code. So what is actually a legacy code? A legacy code is, by definition, is a code without a test. This is what Michael Feeders say in his book, Working Effectively with Legacy Code. By the way, I think if you haven't read the book, you should. It's a must, and also it's getting better by time. And I know that the example mainly are in Java and C++, but you don't. You can apply that in all the techniques that are in this book in many languages. So in my case, I like this definition, but I got a better one. So it's something that it worked for many years. No one knows how it works, and no one also knows why it works, because sometimes you get some feature that deprecates all the stuff, so you don't know. So right here, when we are talking about that, we have what we call lost knowledge. The lost knowledge is how it works and why it works. So the how it works is actually the lost knowledge in dev side, and how it should work and why it works is going to be in the business side. So how do we get back that lost knowledge? at some point, there is always somebody that knows the history of all that code. If you're lucky enough, you're gonna find that person. If you are not lucky enough, you're gonna need some few things to get back that knowledge. You're gonna run some tests. You're gonna do some stuff. So we're gonna talk about that right now. So one of the technique that I use is using event storming. Actually, event storming is an activity. It's a workshop that is used mainly in knowledge crunching when we are talking about domain-driven design. But I use it also I use it also to deal with legacy code. So how it is done? Actually, you gather the right people in the same room. So when you are talking about the right people, those who ask the question and those who know the answer, those who ask the question mainly and usually is going to be the developers. And sometimes it is not the developers. And those who have the answer usually is going to be the business side. In the legacy system, sometimes you're gonna have some developers that know better the application and the business side than the business side, the business people themselves. That's why, like I said, we are talking about those who ask the question and those who have the answer. We didn't specify because in legacy it can change. We provide an unlimited modeling space. So usually you take a room with a lot of space to modulate. And you start exploring the domain starting from domain events. So you use your walls or your space, your unlimited modeling space, using some kind of direction, some kind of timeline, actually. And from there, you're going to explore it. So why do we do that? Of course, to understand how the legacy works in business, how the business see it, how it should work. But also we use that to get two people. Mostly these two people, they found it everywhere in every legacy, most of the time. One of them is what we call the dungeon master, and the other one is what we call the existing system expert. So what is a dungeon master? A dungeon master is actually one of the guys that writing the original software. So they know the history of all of that. So they know how it starts, how the business is done, and all the stuff. But he knows that too well that he can't take a step back to see what is really wrong, what is really done wrong, and how we should fix it. So that's why you need to be careful with this kind of person. You need to get only the valuable and the good information. Not all the information given by the dungeon master are valuable. So you need to be careful about that. Actually, one of the things that I do with the dungeon master when I spot them is doing some mob programming, some pair programming with him. With one rule is he doesn't have the right to let's say to take a keyboard and write something. He needs only to tell me or tell the people that they are with me what they should write, actually, because we're gonna challenge what he's gonna say and all the stuff, and it's gonna be a good practice to understand how it works. And then at some point, when I'm confident enough, I'm gonna try doing some scratch refactoring to see if I understand it well, what I learned from the dungeon master. The scratch refactoring, the link to the compiler, you're gonna find it in the book that I mentioned it later, that I mentioned earlier, of Michael Feathers. So the second person that you need to do, so the first one is really how the work is code, how the code works. So the dungeon master is the guy that knows how the code works. So now we're gonna check the person that knows why it works that way. And that's the existing system expert. So that person usually thinks that he is a domain expert, but actually he is a system expert, an existing system expert. So he knows exactly the system, but in sometimes and in most of the case, he can take a step back and criticize that system. Also, the thing is, can be sometimes a product owner, maybe a business expert, or maybe a QA engineer also. So these are the kind of profile that you need to think of as existing system expert. So what we will ask him is to run a global demo of the system so we can understand how it should work and all the stuff. And maybe to ask them also how they test the application. If it is manually, we are unlucky, but sometimes they automate some few tests. So that's why it can be really interesting to have these people, because you can have a good surprise and maybe you can take their test and run it on the system. So it can be like, let's say, a protection if you need to refactor something, if you need to do something, you have tests that can give you a minimum confidence on what you do. So when we get the history of the system, usually from these two people, first of all, you're gonna identify deprecated feature, dead code also, figure out if there are hidden feature. What we call hidden feature is really, sometimes we call it also customer service. Let me give you an example. A simple example about that is, sometimes one of the customers, they're gonna ask you some export of the data or something to do with the data. So it's not really a business need, but it's what we call a customer service. And you should be aware about that, because sometimes you're gonna find some stuff you will say, hey, nobody needs this stuff, it's not really included as a business need, but one of the customers is actually using it. So these kind of things you need to be aware of. The third point, and really and one of the important one, is sometimes there is a shift in the code domain. So you need to check if there is one or not. One of the examples that I mostly give is about Slack, the application Slack. Slack actually when they started, they were a video game company, and they created the channel to the gamers, so they need to communicate between each other. So it was not really their main product, but at some point they stopped doing video games and they started, let's say, using the channel as their main products. So this is what we call a shift of the core domain. The core domain moved from video games to channel and communication. This is the example that you need to check. And you need always to do that when you are working with legacy code that nobody questioned it for a few years or for many years. So now I think with all the information that we've gathered, we have enough confidence to take a decision. So based on my experience, there is always three choices to do with the legacy system. The first one is when you have really low level of confidence. So what we do actually, you encapsulate the legacy system as a service. So you expose it as a service. You use what we call the pattern in strategic design in DDD as what is called open host service. So you publish the legacy feature as a new one, or maybe as rewrite a new one. And every time you need the new feature, you create it in a bounded context in itself, even as an application in itself, and we call that a bubble context. So here is the schema about that. So this is your legacy system. So nothing go directly to the legacy system. We got the open host service exposing some nice API, some nice features, and managing all the complexity here, doing some mapping, maybe calling something that you don't need to know, something technical and all the stuff. And every new feature is going to communicate by that. The thing about using the open host service is you need to be aware that you shouldn't keep it for a long time. Because I remember in one of when I was working with one of my customers, they've done that, and at some point they didn't know, they forgot. Let's say they forgot, because it's a lost knowledge, how the open host works and what he calls in the legacy system. So beware when you use that the open host service. You need always to keep a place where that knowledge should be kept and never lost. So when you have a medium level of confidence, it's the same. Every time you have a bubble context, you create a new feature when it is needed. But the difference is that every bubble context has his own way to ask information from the legacy system. So we are using what we call an anti-corruption layer. We call only the thing that we needed, but we call it as a whole. So we call the use case service. So we don't care about the database, about the component that we have, about maybe the thing that we call technically, about even the thing that we do. So this is how it works. So these anti-corruption rail represent a use case service. So we call that, and this one is going to really do some mapping only on that use case, calling the legacy system maybe multiple times the legacy system, and even sometimes something externally that the legacy system is using. So this is what we usually do. The thing about this technique is the anti-corruption layer is really incorporating the bubble context. So you need to be careful and isolate it, because it can be really complex. Sure, it's reduced the complexity and also moved the complexity in one place, but it can be harmful for your bubble context. So you should be careful about that. The third one, when you have the highest level of confidence. So every time we ask you to, let's say, to implement a new feature or to bug fix something, you refactor that bug, you extract that feature in bubble context. Or if it is a new feature, so you create it directly in a new bubble context. The thing that you need to be, the common thing that you need to know about all these type of decision is we only do something when we have an opportunity. So we don't do refactoring because we need to do refactoring. We do refactoring because we have a new feature, or we have a bug fix, or we have something. That's what we call an opportunity. This is how we usually work when we are working with legacy code. We don't take risks only if it gives value to the customer. So going back to the point of when you have the highest level of confidence, but you need to know that every bubble context has its own way also. But right here, what is different from the medium level of confidence, the thing that we've seen here, is we are using really some low level service. What we call some low level service, it can be repositories, it can be really, I don't know, maybe something to call email, maybe something to send emails, something to send message, other stuff. So it's really, it will not, the bubble context will not call a high level service. It's going to be calling a low level service. So in this case, we're going to have multiple anti-corruption layer, but it's really, let's say, low level anti-corruption layer. So we have less complexity than if we call, let's say, a use case service. The thing about that is sometimes you're going to have some kind of duplication when you're using anti-corruption layer, and also every time we need to call the legacy system, you need to create an anti-corruption layer. So it can be really it can takes really hard time. But the thing about this technique is when you know exactly how it is done here, at some point you can, when you have an opportunity, like I said before, you can extract this part that is called by the RCL and create some kind of context when you have the opportunity and when you have the time to do it. So to wrap up, take an action only if there is an opportunity. And when we call it, what we call opportunity is really a business opportunity. So it needs to give value to the customer. Don't do it because it's nice to do it. Try to understand how the legacy works using few techniques that we already saw, like mob programming, pair programming, event storming. All these techniques are used really to share information in the most efficient way. Work wisely with the dungeon master and existing system expert, because they can be harmful to the legacy system. Beware, because they've been working for a long time on this system, and like I said, they can have really bad habits that is going to be harmful if you are trying to creating new features or even fixing bug. Also, something else that you need to know is, for the same legacy system, we can have different level of confidence depending on the slice of business that you know. So you can use in the same legacy system, open host service, anti-corruption layer with use case service, anti-corruption layer with low service. So you can combine all the patterns that we've been talking before. It's up to you how you should do it. So that's all. So what's next? Another webinar is going to be scheduled on September. We don't know the subject yet, but I hope we're going to do the announcement soon with Zenica. And if you need also much more information about Zenica, go to the website zenica.ca. That's all. Thank you for attending. If you have a question, I'm all yours. And if you'd like to ask me about something else that's gonna take more time, you can go to the website, ask me using my email, or maybe also ask me asking directly Zenica. Thank you for everything.